Hello, and welcome to Foundations of Data Science at NCSSM. I'm excited that you've decided to join us this semester to learn a little bit more about how we can harness the power of data to search for patterns, make informed decisions, and measure the impact of those decisions. So let's talk about some data science. A good place to start might be, what is data science? It's become a bit of a buzzword that can be confusing to understand what really truly means. Maybe you've heard of business intelligence, artificial intelligence, machine learning, computational science, data analytics, data mining, or some other similar phrase. All of these terms can get used in different contexts to talk about working with data to solve problems. Maybe you've seen a diagram that attempts to capture the different elements of data science, maybe something like this. Here's a common diagram that does a fairly good job at highlighting the key elements of data science. The real key here in this diagram is that data science cannot exist without some sort of real-world problem to solve and expertise in that content area. For example, you wouldn't really do an analysis in the legal domain without understanding something about the law, so that's what we mean by domain knowledge. But just like how data science ends up meaning a lot of things to a lot of people, these diagrams can often get easily adapted to suit a variety of different people's needs, and as a result grow to be a little overly complex. So if you were to continue Googling around for similar diagrams, you might see something like this. At first glance, pretty similar, but this one adds a few labels where the two circles overlap instead of just the middle, and that's fine. Adds a little bit maybe more descriptors, but if you keep looking, you can quickly see that we can have more than three circles or not even circles all together. We have these little ovals over here and we get some more intricate overlapping going on. And wow, that escalated quickly. Before you know it, you have these crazy diagrams which don't really do a great job at clarifying anything about data science. And I want to make sure that we all have a good understanding about what it is we're going to be studying in this course. So how will we think about data science in this course? Data science as a practice has three core activities, and we're going to study all of them in this class. The first of which is exploration. Exploration is figuring out what patterns exist in your data. When you have many observations about some real-world phenomenon, what can you conclude about that phenomenon itself? Oftentimes, instead of just looking at large tables of numbers, we'll draw some data visualizations because it's often much easier to interpret a large amount of information at once if it's portrayed in a visual way. It also helps us discover patterns in some systemic issues perhaps affecting society. Maybe we can study the usage data for a web application, or maybe something a little bit more lighthearted like the trend in TV ratings in the TV show Chopped. The next part that we're going to be studying is statistical inference. Once we've found a pattern, we need to perform some measure of statistical inference to determine if our observation was significant or just from some luck. That's because some patterns that we'll observe are just there by chance, while others are there because they're a reflection of some underlying process that's potentially really interesting about the world or the problem we're studying. So the goal of statistical inference is to quantify whether the patterns that we observe during the exploration phase are reliable. Or to put it another way, if we were to collect more data, would we expect to see this pattern again or not? Our primary tool that we're going to have for using statistical inference is randomization. By simulating processes that have a random component, we can see what kind of patterns would appear just by chance alone. If the pattern that we observe is different from those that would appear just by chance, then we can conclude that it's probably because of some aspect of the underlying phenomenon we're studying, not just due to random chance. For example, if we look at this data here about juror panel selection in Alameda County, California, we can see that the racial distribution for individuals selected to be on the jury panels, indicated here in yellow, differs from the distribution for the county's population, which is indicated in blue. You might want to know, is that difference because of some random chance, maybe just who we randomly selected that week or that year was different than the distribution, or was it because of some other factor? Maybe we're not doing a good job selecting or there's some bias involved here. What we'll do in this course is learn how to simulate what would be likely to happen if we were to select panels at random, which we can see here in the light blue. And we'll find ways to quantify how likely these panels were created by chance as they are required to be done by law. In this particular example, they were not very likely to be created by chance at all. And we'll actually study this exact problem later on in the course. Lastly, we'll be learning how to make predictions from data. This is where we'll have some partial information about something we want to know more about, and we want to guess about the things that we don't know yet. Here we're making informed guesses, not just random guesses. So we're going to be using quantitative guesses using techniques like regression and classification, and those fall into a larger discipline that we'll call machine learning. Now, machine learning is about not programming a computer in a way so that it uses the data where the human needs to lay out every possible decision and pathway, but rather letting the computer figure out what needs to be done on its own. So for example, one possible application of machine learning is to provide a computer with images of different cells in the body that are known to either be cancerous or non-cancerous. The computer can quantify many different characteristics of these images in the cells they contain, maybe number of cells or size of cells, for example, and then employ some machine learning to build mathematical models that can accurately predict how to classify new pictures of cells that maybe we don't know if they're cancerous or not. The computer can pick up on a lot of different hidden patterns in the data much better if there's not some pesky human always getting in the way. So these three stages correspond to how we're going to approach the material in this course. We'll first talk about how to identify patterns. Then we'll talk about quantifying those patterns and determining if they're reliable or not. And finally, based on those patterns, the reliable ones will help us make informed guesses about the information that we wish we knew more about. Once you can do all of that, you'll be well on your way to becoming a data scientist. Now, in the process of doing all of these different things, it's important that we'll learn how to program a computer, because computing underlies each step of the way, and learning the program is just an essential part of participating in the data science discipline. That's it for now. Thanks for watching. I really look forward to working with you all this semester, and welcome to Foundations of Data Science.